Okay, so I've been asked to review stoichiometry. There's a lot of math that's done with stoichiometry. Okay? We did stoichiometry in thermochemistry, we did stoichiometry in gas laws, we did stoichiometry in the stoichiometry unit. In the stoichiometry unit, we pretty much stuck with what's called mass-to-mass stoichiometry, although we did also talk about particle-to-mass stoichiometry. So what is it that joins all these together into the same name? Okay? So what is it that makes stoichiometry what it is? Stoichiometry is the math in chemistry that requires or is built from balanced chemical equations. Stoichiometry is the math in chemistry that requires or is built from balanced chemical equations. So if you have any math in chemistry that requires you to have a balanced chemical equation to solve the problem, then that's stoichiometry. The reason we have to have a balanced chemical equation is because in stoichiometry, whatever the stoichiometry or stoichiometric calculations are, there is a change from one chemical species to another. For the change from one chemical species to another, you have to have a molar ratio, and molar ratios come from balanced chemical equations. Okay? So there's a whole bunch of these types of different types. I mean, I think of it as kind of one thing, but I know that high school students, when they're first starting out, think of it as like a whole bunch of different kind of calculations, but really it's one thing. Okay? So you've asked me to review stoichiometry, and we don't have enough time today to go over every kind of stoichiometry there is. But we can pick one. So which type of stoichiometry would you like to go over?
Do the PV equals...
That's not stoichiometry at all. That's gas laws.
Do particles to mass.
Particles to mass. Okay. So let's make up a problem then. All right, guys. You have to first balance the equation because this is a stoichiometry problem. We're going from one chemical species to another. We're going from zinc sulfide to zinc oxide. So we're going to balance the equation. We use an atom inventory in this class. It's always required in this class. And so I've set up the stoichiometry to this point. I've sort of stopped right here to show you what comes next. Now, here's our starting amount. We're trying to get to zinc oxide. Here's the molar ratio that comes from the balanced equation. So there's a coefficient 2 in front of the zinc sulfide. So down here, there are 2 moles of zinc sulfide. There's a coefficient 2 in front of the zinc oxide. So here there's 2 moles of zinc oxide. So that's where the coefficients come into building the molar ratio here. All right, now I got this molar mass from calculating molar mass the way I've taught you to do it. The next step then is I need a ratio or a conversion unit that's going to get me from moles of zinc oxide to the particles, or the question asks, let's see, how many molecules of zinc oxide there are. So that, in order to get the particles or molecules are particles, I need the ratio that comes from Avogadro's number, 6.02 or 6.022 times 10 to the 23rd particles of anything equals a mole of that thing. Well, since molecules are particles, I can write that as molecules. So this is an equality statement. If I write a proper equality statement, I can build a conversion unit. This side of the equality statement, 1 moles of zinc oxide, is going to go on the bottom because I've got moles of zinc oxide here. So 1 mole of zinc oxide goes here. This goes on the top, 6.022 or 6.02 times 10 to the 23rd molecules of zinc oxide. Okay. Now, you need to be canceling every step. I didn't cancel along the way, but I want to show you how to do that. These all cancel. Grams cancel grams. Zinc sulfide cancels zinc sulfide. Moles cancel moles. Zinc sulfide cancels zinc sulfide. Moles cancels moles, and zinc oxide cancels zinc oxide. When I do the math, I'll have molecules of zinc oxide. That's what the question asks for. So all we got to do is put it in the calculator. This times this times this, hit equals, divide by this, hit equals, divide by this, hit equals. Okay, that's the process I've taught you to use. And let's see, this is what I got. Equals 1.45190315 times 10 to the 23rd molecules. Zinc oxide. I've got 3 digits here, 4 here, 4 here. I want 3 in my final answer. Alright, now let's cover one little thing that this answer might beg a question to. Since zinc is a metal and oxygen is a nonmetal, why does it form a molecule? Okay, since zinc is a metal and oxygen is a nonmetal, why does it form a molecule instead of a crystalline structure the way most ionic substances do? That's because, I've said this a number of times, I don't know if it ever came up in class, that when you have a metal and a nonmetal, yeah, it generally makes an ionic compound, but not with oxygen. Okay, oxygen's kind of unusual, and when you bond a metal with oxygen, you get, it doesn't form a crystal. So I don't know whether you could really call it a molecule or not, but it's not really a crystal either. So molecules is reasonable, even though it's not, you know, what we typically call it. Okay? But we could have called it formula unit, so it would have been fine to call it formula units and been good with that. Okay?